Hi everyone, this is Mrs. Torigno, and I am back with the second part of your Chapter 7 test review. This is the portion of the test review that covers the main part of your test. And on this portion, you are allowed to use a calculator. So before I begin, let me get my calculator ready to go. Okay, this very first question is asking me to evaluate 3 to the power of -4. And pay attention to the fact that it says your answer should be a whole number or a simple fraction. For most of you, when you type that into a calculator, it's going to give you a decimal. So we need to avoid that. Here's how I would handle that. Let's just calculate 3 to the power of 4. If you're not sure what that is, you can type it into your calculator. Just keep in mind that that does not mean 3 times 4. It means 3 times 3 times 3 times 3. That answer is 81. So 3 to the power of 4 is 81. Now the fact that it's negative does not turn it into a negative 81, but rather it flips that 81 to its reciprocal. So 3 to the power of -4 would be 1 over 81. And that would be your final answer. Okay, question 2. Wants you to evaluate 1,000 to the 1/3. I'm going to show you how to do this by hand. However, keep in mind that you could use a calculator to answer this question as well. If you were going to do this on a calculator, just make sure for most of you that you type that 1/3 in parentheses. Really what this is asking you to do is take 1,000 and break it into 3 equal pieces. So I'm going to start a factor tree here. I know that 1,000 is 10 times 100. And that 100 is 10 times 10. And I'm actually going to stop there. Normally we would take those 10s and break them down into 2s and 5s, so each 10 would become 2 times 5. But I want you to notice that where I'm at with this factor tree right now, I have 3 equal factors that make 1,000. So that means my answer is just 10. So 1,000 to the power of 1/3 is equal to 10. That's sort of luck when that happens, that you catch it, but as you get better and better at these, that'll start to happen more often because you'll start to recognize patterns in numbers that allow you to say, okay, I'm going to stop here at this 10 and go down a little further and find a couple more 10s. So just keep that in mind, that you don't always necessarily have to go all the way to the bottom in a factor tree. It never hurts, though, if you do need to go all the way to the bottom. Okay. Question 3. I want you to evaluate 125 over 216 to the power of -2/3. There's a lot of stuff going on in this problem. Here's how I would approach this. First of all, I'm going to handle the 125 and the 216 totally separately. And I'm going to find 125 to the power of 2/3 and 216 to the power of 2/3. So I'll do that, again, I'll do that separately. And you could type this into a calculator. 125 to the power of 2/3 is just 25. And 216 to the power of 2/3 is 36. Now that's not my final answer because I missed something here. I got the 2/3, but I missed the fact that that was negative. So think about what a negative exponent will do to this final answer. And hopefully you come up with the fact that this should flip over and become 36 over 25. And that satisfies what this question is asking you to do. It asks you to leave your answer as a whole number or a simple fraction, which is this right here. So again, I handled the 125 and the 216 separately. I wrote my answer back as a fraction, and then because that was negative, I flipped it over. Just make sure you get all of those pieces in there and you should be all set. Okay, question number 4, sort of a no-brainer. Sort of a trick question also. It gives you 3 to the power of -2, which we could evaluate, but then it gives you that to the power of 0. Hopefully you remember that anything to the power of 0 is just equal to 1. So I should be able to stop myself right there and say that I know that answer is 1. Okay? So if you don't catch that, this one's a little bit tricky. If you do catch that, it's really easy. Okay, let's take a look at question number 5. Number 5 is talking about power functions. f of x equals x to the power of n, so this is some sort of power function. It tells us that n is an even positive integer. So it's basically telling me I know this is an even number, which means this is an even power function. However, this right here where it says x is less than 0 means that this x is going to have a negative in front of it. So really my function should look like this. Y equals negative x to the power of n. Now, I want you to think about what an even power function normally looks like on a graph. Okay, normally an even power function will look like this. It will look similar to a parabola. Okay? However, if this x is a negative number, I want you to think about what that did for parabolas. When you had a parabola and you had a negative in front of it, it flipped your parabola over. That same thing is going to happen here. So really, instead of looking like this time, this graph will be flipped over. It will look like this. Okay? So the range for this function, you'll notice all of the y values are down here below the axis. They're all down below the x-axis. So these are all negative y values, and that's what this is asking. If it's asking for range, that means it's asking for y values. So I would say here that my y values are all negative real numbers. And again, I know that when we talked about power functions, we talked about how even power functions always have a range that is all real positive numbers. But this right here is sort of a game changer. This is saying that there's a negative sign out in front of that x and that it's going to flip your function over. And then question B says, in which quadrants is the graph of f? Well, this little diagram we drew helped us out. And just so you know, the quadrants are numbered like this: 1, 2, 3, and 4. So I would say that this graph is in quadrants 3 and 4. Okay. Question number 6 is asking us to calculate some compound interest. So just so we have it here in front of us, here's that formula we spoke about in class. And you will have this formula available to you on the day of the test. And I'm just going to fill in my values. So my principal, the P, is the amount that I'm putting into the account initially. So that'll be 750 times 1 plus, my interest rate is 3.5%. Don't forget to move that decimal point 2 to the left. So that'll become 0.035. And n is the number of times per year you're compounding. Now keep in mind that's not always given to you in number form, and I know that we like to just skim through these word problems and pick out the numbers, but n is how often it's being compounded. If it's being compounded monthly, that means 12 times per year. So I'm putting a 12 in for n, and that means there'll be a 12 up here at the top as well, because notice there's an n in 2 places in that formula. And then how much will she have after 9 years? So 9 is going to go in for my time. Okay. From here, I would just type straight into a calculator, and I'm going to hope that you can see how I'm typing this in. There we go. So I'm going to type 750 parentheses 1 plus 0.035 divided by 12. No extra parentheses there at all. And then to the power of, and in this calculator I'm going to need to make sure that I put that exponent in parentheses. Some of your calculators, you don't need parentheses up in the exponents, and hopefully by now you know which type your calculator is. But if you're not sure, parentheses are always a safe bet. Okay, let's hit enter. And I end up with $1,027.22. Remember, this is money, so we're rounding to 2 decimal places. Okay, so my final answer here, $1,027.22. Okay, that's it for the first page of your test review. I will post another video shortly that goes into the second page of your review.